It's already on YouTube, done for you. So I'm doing the one, let me make sure we're clear. There's two of them online, right? This is the one that you can print out, right? That's under announcements to print. Does everybody know where that is? Do you know what I mean by that? Right? I'm getting kind of help. So 2 sides and an angle of a triangle are given. Determine whether the given measurements produce 1 triangle, 2 triangles, or no triangle at all. Solve each triangle that results, round the lengths to the nearest tenth, and angle measures to the nearest degree. So, all right, look at those answers. These can be kind of tricky. Look at those answers. 2 triangles are possible. There's a couple of capital B answers. No triangle, 1 triangle. Kind of weird, huh? Remember this? Sort of, kind of? All right, let me make it a little bigger. Things too. So what do we do? What should we do? Let's start out there. In fact, yeah, you know what? Remember that? So I'm going to I'll just draw it over here. And it doesn't matter what it looks like, who cares? And I'm going to put A here, B here, C here. You don't have to put, that's what they usually did, but it doesn't really matter. And the little a is across from the A, the little b is across from the B, and the little c is across from the C. That's what matters, right? A across from A, B across from B, C across from C. So start there. So A is 75 degrees there. Little a is 4. Little b is 8. Because we have a side of the angle across. Whenever you have, a matchup, any angle on the side across, law of sines. If you don't, law of cosines, right? And it's not a right triangle, by the way, so we can't use any SOHCAHTOA stuff from the earlier chapters, right? It's not a right triangle. That's what's unique about this whole chapter 4 that we're in now. No more right triangles. So we can't do the SOHCAHTOA stuff. We can't do SOHCAHTOA. So we have to use law of sines and law of cosines, which are true for all triangles, not just right triangles like SOHCAHTOA. So yeah, and it's law of sines because you have an angle and the side across. Whenever you have angle and side across from it, that is law of sines. If you don't have that, which we'll see in a couple minutes, then you have to use law of cosines. That's the big difference. So you're going to set up law of sines. How does law of sines work? A over A, B over B, C over C, huh? Yeah. So yeah, law of sines. So I'm going to go A over sine A, right? A over A is B over B. And what's B? 8 over sine capital B. A over A, B over B, right? Take it from there. All right, so, so diagonal, 4 sine B is 8 sine 75. Then we got to solve for the B. So what's my next step to solve for B there? Divide by that 4, right? Boom. So then we get sine B. 8 divided by 4 is 2. Like that. And then just use your calculator. I don't know what 2 times sine 75 is. So 2 sine 75. I'm getting 1.93185, whatever. And then how do you finish? Sine inverse. You go sine, because that's how you get rid of a sine, huh? Sine inverse. So sine inverse on both sides. It cancels out. B equals, and it'll say no. I mean, it won't say no. It'll say error, which means not possible. So that one is not possible. Is that music making the lecture seem a little more cool? Would you mind just turn down a little bit? Thank you. All right, so are we good there? So is that all making sense? So that one's no triangle. All right, let's go see. Let's try that one. Let's see what you know. Can you read that okay? Oh, find the area. Yeah, that's find the area. That's a little different, huh? I thought we were going to do another 1 triangle, 2 triangle thing. Right, they're giving me A, C, and the other angle. So it's super convenient. If you have that formula written down, this will be a piece of cake. This one will be easy. So you just go, the area equals 1/2 A, so it's 1/2 times side 1 side 2, sine of the angle between them. Angle between. Right? And there's 3 ways you can write that out. It's 1/2 AB sine C, or 1/2 BC sine A, or 1/2 AC sine B. They're all saying the same thing. What did they give me? They gave me the third one, so that's what I'm going to do. 1/2 times A, which is 4, times C, which is 7, times the sine of the angle in between, 10 degrees. Hit the buttons on your calculator. I'm getting 2.431. 2.431. Oh, they want you to round to the nearest square unit, 2. There we go, 2. It's a rough round. It's a very abrasive rounding there. All right. There we go. So that one will be, if you have that in your 3x5 card, that'll be a freebie. Good? I'll move on. Want to start number 3? Yeah, I'll just leave it on screen. Go ahead and start number 3. So the plane, I'm gonna have it going up. You can have it going right. Doesn't really matter. The plane's going, let's say, this way. Plane's flying north. Okay, doesn't matter. I'll redo it. Going to the right. So it's going north, and the plane is flying a straight course. So it's going straight line. It's not zigzagging or anything, right? Plane's going in a straight line, and he observes a mountain. He goes, look, mountain, at a bearing of 32.5 to the right of its course. So at some point, he makes an observation. Let's say right here, whatever. He's flying, he looks over, he sees a mountain 32.5 degrees to the right of its course. So here's my course, 32.5 to the right of that. So like, let me put it further off. Let's say up there. He sees M for mountain at 32.5 degrees to the, that angle here, right, to the right, 32.5 degrees to the right of my course. My course is straight up. Or I could have made it straight to the right. It doesn't matter. Right, y'all with me? Right, you could have made him flying straight to the right, for example, and he observes the mountain over here, 32.5 degrees to the right. So it doesn't matter. Right, we don't care which way he's heading originally. He's heading in some straight line, and as you're flying, and you look to the right, 32.5, you see a mountain off in the distance. Get the idea? Now, at that time, at that first observation time, the plane is 6 kilometers from the mountain. So this is 6. This is 6. I'm just drawing 2 different pictures to help, to show you it doesn't matter, up, right, whatever. Right? From observation to mountain, 6 kilometers. Observation to mountain, 6 kilometers. Okay, now, a short time later, remember he continues on his straight. That's important. Straight flight. Short time later, the bearing to the mountain becomes 42.5. He makes another sighting. He looks over and calculates the bearing again. Let's say right here. And now, whoops, then he zigzags now. He looks over, and the bearing, now where do I do the bearing? Right here. The angle becomes bigger, 42.5. Does that make sense? The bearing, do you see why I do it? The bearing is from your heading. From straight up, if you're going straight up, or from straight right, if you're going straight right, right? You're heading straight up, and you look to the right, 42. But now it's a bigger angle because, you're getting closer to the mountain. That makes sense? You could have done the same thing here. Just take the second one here, and that would be 42.5. So you could do it going straight right, straight up, you go left, down, whatever. See how that part doesn't matter. Same triangle setup either way, huh? Everybody see that? That makes sense? So that just takes practice. Just reading words and putting them into pictures. More and more. If you want to move up the line, math science, you really got to practice that because they make you do it more and more and more. So that good? So now it's time for trig. So that's enough with the picture stuff. Now we've got to do some trigonometry. And what do they want? What do they even want from me?
They want to know how far he is away from the mountain.
Yeah, that last sentence has the question, huh? How far is the plane from the mountain at the second bearing? In other words, X there, huh? Or X here on my other diagram. Right? They want to know that side of the triangle. How far is he from the mountain? Interesting, isn't it? That you can figure out distance this way? Kind of like, remember, have you heard of the phrase triangulate? That's kind of like what we're doing here, aren't we? Right? When we're flying along, by taking one angle and another angle, we know this is 6 miles, and then another angle, we can figure out the mileage based on how far we are, the kilometers, based on how the angle has changed on our course. Kind of interesting. So, all right, how are we going to find that x? Let me let you take it from there. Getting the deal. So what are we going to do? What trig thing? It's not a right triangle. We're not going to do any SOHCAHTOA, are we? So it's either law of sines or law of cosines, right? Because it's not a right triangle. So we can do law of sines or law of cosines. How do you know we're going to do law of sines? Yeah, we have angle and side across. That's the main thing, right? Remember back here I said, when you have an angle and a side across, law of sines. Right? So we can get this angle here, can't we? Right? How are we gonna get that angle here? Subtract from 180. Right? Because that's not a right angle there. That's a straight line. That's 180. Right? Notice if you're going straight up and you turn around, that's like making a U-turn, right? What do they call it? A 180. Right? You're driving down the road and you turn to go the other way. Right? If the plane's going straight up and then it turns through this whole angle to go down, that'd be a 180. That's from straight up to straight down. That's 180 degrees. One side of a straight line. It's not 90, right? 90 would be if they had a right angle in there and you were just doing the little part that was left for 90. It's 90 and 90. It's 180, isn't it? So, all right. So it's going to be subtract from 180. So this angle here is 180 minus 42.5, which means it's 137.5. Is that right? Yeah. Okay, so 137.5. So we have that angle and the side across from it. So law of sines for sure, huh? Whenever you have an angle and a side across, you want to do law of sines. So that means, remember how law of sines goes? Side, so the side over the sine of the angle. So 6 over sine of 137.5 is x over sine of 32.5. Everybody good with that? Right? Side over side of angle, sine of angle, and side over sine of angle, and then cross multiply, solve for x. Right? On that. Cross multiply. So then we have 6 sine of 32.5 degrees is x sine of 137.5 degrees. Last step is divide by the sine of 137.5 degrees. Boom. X equals, that what we did, 1.77? 4.77, thank you. 4.77 rounds to 4.8. There we go. How are we doing? Do you all see that? Questions I can answer on that? Everybody see what happened there? So I found the angle and the side across, side and angle across. Law of sines. But it all came from the picture. Questions? Good. All right. I better number 4. Solve the triangle. They're giving me B, C, and A. Capital A. Solve the triangle. They just want you to find the little a. All right. I'll let you do that. Give you a second. Yeah, so when we draw our triangle here, we go capital A, capital B, capital C, little a, little b, little c, and we see, okay, what are they giving me? Little b is 5, little b is 5, little c is 6, and capital A is 70 degrees, like that. Notice I never have a complete pair. In other words, I don't have this angle and the side across. I just have the angle. I don't have this side and the angle across. I just have the side. I don't have this side and the angle across. I just have one of each, don't I? I never have a complete angle and side across, so I can't do law of sines. I never would have a complete fraction. To do the law of sines, I couldn't solve it. I'd have half of all of them. You know what I mean? If I tried to do, you see what I mean? If I tried to do law of sines, watch me try to do it. If you tried to do law of sines, you would say, okay, 5, like B, over sine B. I don't know. Then I'd go 6 over sine C. I don't know C. Then I would go A over sine 70. See how I have half of each one? There's just no way I'm going to solve for anything. There's a letter in there's something unknown in every one of them. No, I'm not going to get anywhere. All right, so you can't do law of sines. There'd be too many letters to solve for anything. So you got to do law of cosines. Yeah, so law of cosines. So let me write that out again. So the law of cosines, again, is a squared is b squared plus c squared. Let me write it down for the benefit of those watching the YouTube. So the a goes to the a, or you could do it this way. It's the other two sides squared minus 2 times those two sides times the cosine of the opposite angle. Or c squared is other two sides squared minus 2 times those two sides times the cosine of the opposite angle. All right, any of those versions will work. What do we have? We have that. So we have this triangle thing. Capital A, capital B, capital C, little a, little b, little c is 6 and 70. Okay, so this is question number 4. All right, so question number 4. Let's finish up then. All right, so law of cosines. So which version am I going to use when I do law of cosines? This first one with a squared, because a is what I'm trying to find, huh? So I'm going to use that one. So I'm going to use that one. So a squared is b squared plus c squared minus 2bc cosine a. So a squared, I don't know what a squared is. B squared plus c squared. So 5 squared plus 6 squared. If it was a right triangle, that'd be it, huh? But it's not a right triangle. It's 2 times b times c times the cosine of the angle in between, capital A, 70 degrees. There we go. So little a squared is that. Minus. I'm getting 40.47879, and then root it, huh? So then I just go second square root of answer. I use the answer button. You guys know how to use that? It's real convenient. You don't have to write it down and type it in again. 6.36. Do they want round 6.4? Okay. 6.4, 6.4. There it is. We good on that? See how we knew law of cosines? Because we never had a side and angle across. We never had a complete fraction to make the law of sines work. So we had to do law of cosines. All right. These ideas coming together for you? You guys are trying. So how do you do magnitude? Yeah, it's the square root of, it's like the hypotenuse of a triangle. That's what it really is, right? Every vector is the hypotenuse of a right triangle. Do you picture it that way? Right? If you were to draw this vector, minus, if I remember, I is sideways, j is up and down. So this is back 5, up 12. Back 5, up 12. So there's the vector. That's vector v. He's back 5i, up 12j, which means he's a right triangle. His magnitude means his length his length is his hypotenuse, right? Every vector is the hypotenuse of a right triangle. You catching that statement? That'll help you if you're going into high. Like I said, doing physics with my daughter all the time right now, and all these vectors everywhere. They're all the hypotenuses of right triangles. So you just do the hypotenuse formula. So what do we get? It's the square root of 25 plus 144, root 169, 13. Oh, and they want the angle too. Oh, okay, a little more work. We're not done yet. All right, so we got the length. That's the easy part. They all say 13. What did we accomplish? Oh, no, one of them's out. Yeah, no way, see? All right, so we got that one out of the way. But, yeah, what do we do now? So now, find the angle. Let me give you just a second rather than me just doing it. This is harder. I'm going to go to fresh screen to find the angle. All right, so to find the angle, now, let me do it wrong first. Here's the mistake, because if you just simply have the formula, tangent of theta is j over I, that's not really the whole story. You'll get it wrong. You'll go, okay, so then theta is just the inverse tangent of j over I. And what's j? 12. What's I? Minus 5. Hit the buttons on your calculator. This is going to be totally wrong. Tangent inverse, 12 divided by negative 5. You would get theta is negative 67.38 degrees. That's what my calculator just said. So, uh-oh, that answer's not there. Negative 67. Should I just grab the 67?
No.
What should I do? What went wrong? What's happening? Well, it's all that screwy stuff with the inverse trig functions, you know, about what quadrants, they can do this and that. Remember, that's a problem. So, to make it easy, what do you got to change? That's why I gave you a rule. I did different than Math Excel. They have I think, a harder way. So I tried to make it super simple for you. The reason it's coming out weird is because of all that weird restrictions on the inverse trig functions. The way to get around that is you just do positive. Come on, positive only. Get a first quadrant answer and then shift it to the appropriate quadrant that you find by drawing it, which you already saw me draw it. It's in the second quadrant. It's got to be more than 90 for sure, right? So did you catch that again? So positive only. Get a first, get a reference. Yeah, get a first quadrant reference angle. So the way I deal with all the weird restriction thing is I say, look, just make it positive, get your reference angle that way, and then adjust based on drawing.
So we would do like
correct quadrant. What's that, Kevin?
We would do like 180 minus the 67.4.
Yeah. Good. So let's do it correct. So is everybody seeing this game plan? Sorry, I'm kind of being scribbly there. Can you read all that? So step number 1, do positive only. Get a first quadrant reference angle. Step 2, adjust it based on the drawing to the correct quadrant. That's the way to do it. So if you make them both positives, see, the mistake is I made that 5 negative. So if you make him positive, then you'll get positive 67.38, won't you? Isn't that what you get there? Yeah. Good. So you get that. Now, that's still not my answer. That's my reference angle. So now you do the drawing. You draw the thing. What do you mean draw it? Back 5 up 12, right? Like I did. Back 5 up 12. Back 5i. Right? I is sideways. J's up, down. There's the actual vector v. So the 67.38, what's that? That's a reference angle. What does that mean, reference? We've been talking about that for more than 2 months. With reference to what? The x-axis, right? You guys are pros at that now. That means that's this angle, huh? This angle is 67.4, I'll say. 4 degrees. Off the x-axis in the second quadrant. So what does that mean? They want the actual angle. What do I mean by actual angle? Are those two words clear? Reference is from the nearest x-axis. What is actual angle?
From 0.
From 0. from 0, which is here. So they want from there to there. That's the actual, or what they'll call in higher math, they'll call that the direction angle. Well, they even call it here, that way. Yeah. Right here, they'll call it the direction angle. Not just higher math, we're getting into higher math. Yeah, direction angle, meaning from 0. So how do you find that? You know, that's 180, subtract the 67.4. What is that? 112.6? There it is. Oh, no. C's the bad answer. It almost got me. It's A. All right, there we go. Does that make sense? We'll do a ton of those, so you really want to get used to that. So how do you find the angle, the direction angle of a vector? You do tangent inverse of positive j over I. Get your reference angle, draw it, and adjust it for the correct quadrant. We'll do a ton of those in the next chapter. So the angle is 112. So in other words, this vector is 13 long, headed in the direction 112.6 degrees. So you're like ready for physics with that ability. That's literally the first thing, the first day in physics, the teacher gave them a bunch of vectors. It was a bunch of vector problems. And I remember my daughter, Lizzie, who's been through Calc 1, Calc 2, Calc 3, came home and said, Dad, can you help me with these vectors? I'm like, honey, you've done a ton of vectors. She's like, I know. But when it's like this real world kind of thing, I don't know where to put the vectors. Right? That's always what's hard, right? There's the math, and then you get into something real with it, and it's hard to get used to where the vectors go. So you want to have this down so when you get real, you can handle it. So if you draw the picture here, A, B, C, little a, little b, little c. Okay, they're telling me big B is 41, little a is 4, little b is 3. Okay, so see, these two say, do law of sines, please, don't they? Whenever you have a side and the angle across, you've got a matching pair for the law of sines, right? So when you have side and opposite angle, whenever you have side and opposite angle, do law of sines. So that's how I know I'm going to do law of sines, not law of cosines. We'd rather do law of sines, right? That was easier. So if we have a side and the opposite angle, you're always going to do law of sines. Okay, so let's set up law of sines. So it's going to be 3 over sine of 41 degrees, right? The side angle is, and then what's my other pair? Well, this is the other side I have here. It's going to be these two. 4 sine A. We good there? So now, how do we solve this? We go diagonal, diagonal. So 3 sine A is 4 sine 41 degrees. Diagonal, diagonal. What's next? Divide by that 3. Divide by that 3. So then, bring it over here. Sine of A is something, I don't know. So go divided by 3. Sine 41. I'm getting 0.8747. Remember, you want to use a lot of accuracy when you're in the middle of the problem. Use a lot of places, right? Don't round it to like 0.8 or 0.9. You're going to mess yourself up. Right? Use a lot of accuracy when you're in the middle. Use a lot of decimal places when you're in the middle of the problem. So sine of A is 0.8747. How do I get A?
Sine inverse.
Sine inverse, huh? So I'm going to go sine inverse, sine inverse. So I just use what's on my screen. I go sine inverse and hit the answer button, right? I don't have to write stuff down. It's even more accurate and it's quicker. So capital A equals 61.015 or 014, whatever, degrees. 61. So there's my answer. 61.015 0.04 degrees. There it is, one triangle, 61 degrees. Answer A. Got it. Wait, is that right?
You can check.
Or should there be, or could there be two triangles? Are there two? How do we know?
If there were two triangles, C would be A equals, the 61 that we thought plus something else. That's not an answer.
So how do you find the other possibility for A? Let's start there. Do you remember?
You subtract the 61 from 180
Yeah. Why?
because if that other angle is like enough to have the 41 in another triangle, then it can be another triangle.
Well, that's the following reason. But the reason you subtract from 180 is because that's it. It's the same thing. That's the same reference angle in the second quadrant. So let me write this out. So let's how do I say this? When you, what's the situation here? So it's when you're solving a triangle with the law of sines, you take your, let's say. First angle, also take 180 minus the angle and see if that fits in the triangle for all three angles. See if that also fits in the triangle for all three angles totaling 180 degrees. Is that sentence making any sense? So whenever you're solving a triangle with the law of sines and you get your first answer angle, you get your first angle answer. Also take 180 minus that angle. Call that your second angle, and see if that also fits in the triangle. So let's do that. Why 180? Because remember, it's that weird stuff again about the restrictions on the inverse sine, cosine, tangent. Basically, remember the sine can be positive. Remember, all students take calculus. Sine is positive first and second quadrant. There's a second quadrant answer, right? Because you think, well, no, why didn't the calculator tell me? Well, the calculator is programmed to only give you one answer when you do sine inverse, cosine inverse, tangent. But there's actually another answer. Remember, whenever we go to the unit circle, we get two answers. We do the inverse things. There's another place where sine is positive 0.8747. It's not just the first quadrant. Sine is positive first and second quadrant. So there's also a second quadrant answer. Now, it may not fit in the triangle. It might not. That's what you got to figure out. That's how you know one triangle or two. So anyway, you don't need to know all that theory. That is the but we have been over that. So I do want you to be exposed to it. Hopefully you grab that. So there's a second quadrant option. So, and in the second quadrant, so we got what angle did we get here? 61 degrees. So if 61 is, that doesn't look like 61. 61 degrees is first quadrant. There's also a 61 degree reference angle in the second. So how do you find that? 180 minus it, huh? That's why I'm saying it's 180 minus it, because it's the second quadrant, same reference angle. So the second angle, you've always got to find the second angle, is 180 minus 61 would be 119 degrees. Now, we'll say maybe. Does 119 fit in the triangle? We're saying that's angle A, right? Isn't that A? Yeah, A. So we're saying A can be 119 or A can be 61. Maybe. Does it? What's B and C? Don't we already know B and C? Or we know B. B is 41. So we already know B is 41 degrees. How much would that leave for C? Right, because B is 41. How much would that leave for C? Yeah, if you add up and subtract from 180, so what that is? Yeah, 20 degrees, huh? C would be 20 degrees. So they got to make 180. So I just subtracted there from 180. So I got that 180 minus 119 minus 41. Everybody with me? That's how I got that. So it works. It's possible. Are you tracking me? Now, you think, well, how would it not work, Mr. And what if B was like 84 degrees? Then no way. 119 and 84, you're already over 180. There's nothing left for C. There's no way. Then we would throw out that option for A and say, no way, A can't be 119. Is that making sense? We'll probably have one of those in a minute. Maybe not, I don't know. So is everybody seeing, I know this is confusing. One more time. So whenever you're using law of sines to solve a triangle and you get your first answer, you've got to take 180 minus that. So I hope you write this on your 3x5 card. Just write this example. Get your second angle and see if it fits in the triangle. So I got 180 minus my first answer. Got 119. And then I went back and grabbed B. Angle B was 41. Oops, I just erased it. 41. And then, took 180 minus those two and said, yeah, that does leave room for angle C. Doesn't it? So that fits. That's possible. So A can be 119 or A can be 61. There's two possible answers for A. 119 or 61.
So on the choices.
Yeah, so what about the choices? A can be, let's go back and look at the choices. So we have our answer now. Right? Everybody good on the answer? A can be, keep erasing it, 61 or 119. They both fit. So A can be so one triangle with A 61. No, there's two triangles that are possible here. No triangle. No, that's not right. Two triangles. A is 29 and 151. No, it's two triangles, but not those A's.
And 151 would be 11.
One triangle with 29. No, none of the above. With confidence, right? That's a tricky none of the above, isn't it? Are there 8 none of the aboves?
8.
That was none of the above. All right, we good there? Does that make sense? Everybody understand all that stuff we just did? Yeah. Yeah. So when you're doing law of sines and you get your first answer, 61 degrees here. So when you get your first answer from law of sines when you're solving a triangle, you've got to also take 180 minus that and see if it fits in the triangle. That'd be the short story. So when you get 61, then you go, okay, maybe, but I also got to take 180 minus that, and 180 minus that is 119. See if it fits in the triangle. What do I mean fits in the triangle? Well, we already have another angle. Yeah. If those two make more than 180, then it doesn't fit. You don't even have to find C, really. Maybe I should have even shown that. Who cares what C is, right? I just have to make sure these two are not more than 180. If they're less than 180, then there's room for C, whatever it is. Who cares what it is? As long as there's room, right? So as long as these two don't go over 180, then there's room for him. He's a possibility. But if it's over 180, it's not possible. Make sense on that? So that was a tricky none of the above, wasn't it? They're trying to trick you. You good with that? You won't be tricked, right? Anybody have a game plan?
The whole thing's a right triangle, right?
The whole thing is a right triangle.
So could you use tangent to find like the whole?
Yeah, call this whole thing something like y or whatever. Yeah, good. So use the whole thing, call that y, tangent of what? 48, which is that whole angle there. Yeah, so just looking at the whole triangle right now. Good idea. Look at this whole big triangle. Forget about the inner stuff. And just look at that whole big triangle. So the tangent of 48 is, remember, tangent is always TOA, opposite over adjacent. So opposite y over adjacent 60. Is that good? And then we could solve for y, couldn't we? Now that's not our answer yet, but that'll be a good step in the right direction. It's a good, yeah. You're going to have to do a couple steps on this. This is a multi-step problem. It's not a one-stepper. The reason is why? Why is it not just a one-stepper? Because A is not a whole side of a right triangle. He's a part of a side. See how they're being tricky? See the deal? Now, A is a part of the right triangle, isn't it? So that's kind of tricky. So we have to, basically I'm going to do, you guys are right on the money, is what we're going to do is find the whole thing and then find the little piece here is also a right triangle and then subtract them and we'll get A. Does that make sense? I'm going to find y first, then I'll come back and find x, which is there to there, and then y minus x will be A. Those are two right triangles. The whole right triangle, the little right triangle. Two tangents. Find y, find x. Subtract them. Okay, so let's solve for y. How do we solve for y here? By 60. Boom. Y equals something. What is it?
66.63675.
All right, let's go 636. Good. Okay, that's y. Now let's do the little triangle. So now I'm just going to hone my attention on the little triangle right here. Just the little right. See how there's a big right triangle, the whole thing's right triangle, and then there's a little right triangle, huh? I'm using that right angle twice. Tangent again, right? Tangent of 37 degrees. Now just this angle is x over 60. Now I can solve for x, huh? Multiply both sides by 60. X equals 60 tangent 37, 45.213. So I've got y, I've got x. A is y minus x, huh? It's 66.636 minus 45.213. Yeah, 21.4. How far do they want me to round? Yeah, 42. There it is. D. Does that make sense? So it's kind of tricky. It's a two-stepper. The big right triangle, little right triangle. Find the whole side and the bottom part and subtract them, you get A. All right. All right, so how do I find this angle?
Subtract 180.
Subtract from 180 again, right? Because that's one side of a straight line, which is 180, right? If you're headed this direction and you turn all the way around to head this direction, you did a 180, didn't you? Right? If you're going this way and you turn around and go the other, that's a 180. One side of a straight line makes 180, doesn't it? So that's a 180. So if I subtract from 180, so this angle here must be 180 minus 52, which is 128. 128, yeah. That's got to be 128 degrees. That angle there is 128. And now, how can I find this angle up here? Because every triangle holds 180, right? Do you know that rule? Of the three angles, any triangle, the three angles total 180. So yeah, so if I take 180 minus the other two, minus the 128 and minus the 28, I'll get whatever I get. Yeah, 24. So that must be 24 degrees. Okay, so what? So I've got all the angles. Now do you see what I can do? Now I have an angle and the side across from each other, don't I? I have a pair. I could do law of sines now. See, I have angle and side across. As soon as you get angle and side across, you know you can do law of sines. So law of sines says 2.3 over sine 24 is what? What do I want here?
You want to find
A. So that'll be these two. Little a, sine of the 28, huh? There we go. Cross multiply. Done that a few times. 2.3 sine 28 is little a, sine 24. Last step to get little a alone. Divide by sine 24 degrees. Hit the buttons on your calculator. 0.3 sine 28 divided by sine 24. 2.3 6, 5, 4, 7, whatever. There it is. Answer C. We good? Questions on that one? That's some little tricky triangle work there. All right, 18. Probably use up the rest of our time. Let's see. Two forces, F1, F2, magnitude 60 and 70 pounds, respectively, act in an object. The direction of force 1 is north 40 east. Direction of force 2 is north 40 west. Find the magnitude direction angle of the resultant force. Express the direction angle to the nearest tenth of a degree.
So one is 40 east, the other one's 40 west.
Yeah. So you need a picture. It's not super important. I mean, you could really do it without a picture. It's not like the airplane one where the picture was really important. So two forces, definitely a physics problem here. Two forces acting. So draw. So I would draw, on these, I would draw the axis system. Just put it right at the origin to make life easy. And then make one of the forces is north 40 east. So draw an arrow, a vector, force is a vector, north 40 east, and what you want to do is turn it into I and j. Remember these? You want to turn both those vectors into I and j, and then you add them. That's how you do a resultant. That's how they do it in physics. That's exactly what they do. So you make the first one ij, the second one ij, and then you just add the two vectors together to get the resultant. That's what they want. The resultant force. So add the I with the I, the j with the j, get the resultant vector, but then you got to turn it back into, when you're all done, back into magnitude and direction. So it's a long problem. It's all we're going to have time for, probably. So try it out. So first off, change F1 and F2 to I, j vectors. Add them. Step 3. Change back magnitude of the vector is square root of I squared plus j squared, and angle theta is inverse tangent of the positive j over positive I, but then reference and quadrant, all that stuff we talked about. So there's the 3-step game plan. Step 1, change F1 and F2 to ij vectors. Step 2, add them. Step 3, change them back to magnitude and angle. So those are the 3 steps required. Vector, so force 1 is north 40 east, so that's going to be like this. Force 1, 40 degrees. Yeah, the other one is west. Force 2, huh? So force 1 is north 40 east, force 2 is north 40 west. All right, you got to turn those into I and j. Remember, how do we turn forces into I and j? Remember what it always is? Force 1 is, how much is force 1? 60. Force 1 is 60. So it's 60 pounds in that direction. Force 2 is 70 pounds. It's a little harder force, stronger force in the westerly direction, northwest. So anyway, yeah, so remember what you do? You just take the magnitude, the 60, times cosine of the angle. Oh, but you got to get the angle first off. It's now 40 degrees. What do I mean when I say the angle? The real angle from 0, huh? The direction angle, they call it. Yeah, you got to get the real angle from 0. So what's the real angle for this vector? 50, right? Because it's 40 off of that. It's 90 minus 40, which is 50. So for vector 1, the real angle's 50. Because it's from 0. So if it's 40 off of the y-axis, it's 50 off the axis, right? 90 minus 40. You with me? So it'd be 60 cosine 50 plus, I forgot my I there. I plus 60 sine of 50 J. Remember how it's always magnitude cosine for I, because cosine is sideways, cosine is always x, right, all semester long. Cosine has been x, sine is y. So it's how it always is. So you want to put that in your 3x5 card, for vectors. So whenever you want to maybe put this 3-step process on your 3x5 card for vectors and how to convert to I and j, you got to get the actual angle. And it's
the direction angle you use.
Yeah, always use the direction angle. Yeah. Can you do force 2 now? And then, of course, you need your calculator. I'll do the calculation in a minute. But can you set up force 2 vector? You got to get the actual angle of force 2. It's not 40. Meaning from 0. So you got to get force 2 from 0. So from 0 to force 2 vector, it's 90 plus 40, isn't it? Everybody see that? Because it's 40 off of this axis. Everybody clear where that 40 is coming from? Right, so it's 90 plus 40, isn't it? $130. Are you seeing that? Am I confusing you? Because force 1 and force 2 are off of the north. So it's 40 off north to the right and 40 off north to the left. It's 40. So that means to get from 0, you got to go 90 and 40 more, don't you? So that'll be 130. So that'll be 70 cosine 130i plus 70 sine 130j. Is that making sense how we do that? How we turn angles and magnitudes into IJ. Now we got to use a calculator. Get the numbers in your calculator. I'll go to a fresh screen if you guys got all that copied down. I'll go back and forth. So I'm getting force 1, 38. Use a few places of decimals. 567i plus, what is it? 60 sine 50. 45.963. 0.963j. Force 2 is 70 cosine 130. Negative 44.995i. And 53.623. So we okay? You guys all making sense out of that? All right. And then so that's step 1. We changed them to IJ vectors by getting the actual angles from 0 and multiplying the magnitude times cosine for I, magnitude times sine for j. We get them and now we add them up, don't we? The result. The resultant vector. What's the result of those two forces? Right? If those are two forces pushing on an object, one upper right, one upper left, what's going to be the result of those two forces? You just add the I with the I and the J with the J. So 38.567 minus 4. I'm getting minus 6.428I. Plus 99.586J. We getting that? So that means there's what? 6 pounds of force left, 99, almost 100 pounds of force up. That's the result of those two forces of, what was it, 70 pounds upper left and 60 pounds upper right. See why there's a little bit more left than right? Because the 70 pounds was stronger to the left than the 60 to the right. There's a little more left than there is right. So the net result is a little left, but mainly up, right? Almost 100 pounds up. Makes sense. All right, final step, change back. How do we change? The magnitude of the vector is the square root of this one squared plus this one squared. So square it plus 6.428 squared equals second square root of answer. I'm getting the magnitude of the vector 99.793. And last thing, they want us to get the angle. How do you get the angle? Tangent inverse of the positive j over positive I. So tangent inverse of the positive j, 99.586 over the positive I, positive 6.428. And I'm getting theta equals 86.307 degrees. But that's just a reference angle. Where is the vector actually? Look at this vector. He's left and up, isn't he? So this vector is here. See, left. This is left and up. So he's there. So that 86 thing, that 86 degrees is from here. This 86 degrees is from there. It's the reference angle from the x-axis up to there. So what do you got to actually do? Take 180 minus it, minus the 86.307, and you get 93.693 degrees. Right? It's got to be more than 90. It's heading in a 93.693 degree direction. There's the angle. There's the magnitude. One of those answers there?
Yes, A.
It's A. All right. Whew. That's all.